Okay, welcome to video 10-4A. This is the first of 3 videos for 10-4. And in Explain 1 here, we're going to be proving the properties of a parallelogram. So we are going to be using, we've already used the distance formula and the midpoint formula in some of these problems that we've done in our evaluate sets. We're also going to be using slope again in this proof here. Our example 1 asks us to prove or disprove that the quadrilateral determined by the points A, B, C, D, given as such, is a parallelogram. So it's not giving us the answer. It's not telling us prove that it's this. It's saying, is it a parallelogram or not? Now we figure it out. So what they're seeing is using slopes to write the coordinate proof. If it's a parallelogram, we're going to find 2 pairs of parallel sides. So we're going to get slopes of opposite sides being the same. So slope of AB we calculate and we get 3. Slope of its opposite side CD we calculate and we also get 3. So there's 1 pair of parallel sides. And then slope of BC we're going to look at and we get 2/5. And then the slope of DA we also get 2/5 when you plug in all those awesome numbers. So as we compare slopes, the slopes of opposite sides are equal. This means opposite sides are parallel, and so yes, it is a parallelogram. So let's go to our next page. Part B of this same example 1. Now we're going to use the distance formula to do it instead. So instead of comparing with slopes, now we're going to do this with the distance formula. So this one I know can be a little tricky because of all the different spots that we have to fill in with the distance formula. They've written us the distance formula again, so I'll just highlight that for you. Remember, it's the square root of x2 minus x1 squared plus y2 minus y1 squared. So it's the same subtractions that you're doing in the slope formula. It's just that you are squaring them and adding them together and then taking the square root. Okay, so let's fill in what we need here. And in order to find the distance between A and B, and what I would again caution you to do is to make sure you have a list of points. So let's write that up at the top here. A is the point 4, 4. B is the point 3, 1. C is the point -2, -1, and finally D is -1, 2. Now I know that was listed on the previous page, but it does help to make sure that it's close to the calculations that you're doing, so rewrite it again. Okay, now we're going to look at, again, the distance between points A and B. And so we're going to subtract our x coordinates, so it's 3 minus 4. And then they filled in the rest of that for us. So again, it's 1 minus 4. And then each of those pieces is squared, remember. So -1 squared. And then we need to do this subtraction. It's -3 squared. And if you just do a quick little addition off to the side there, you realize it's 1 and 9 that's being added under the radical, so that's radical 10. Now, remember, with determining whether it's a parallelogram using the distance formula or the lengths of the sides, now opposite sides have to be the same length. So if we've already looked at AB, we now need to look at CD, its opposite side, and see if that also holds true. In this case, we have -1 minus something, and that something is -2, the other x coordinate. And then also 2 minus -1, subtracting that. We're going to get +1 squared and +3 squared. So again, you can see off to the side that would be 1 squared is 1 and 3 squared is 9, or a radical 10 again. So now we've got one set of parallel sides, or excuse me, one set of congruent sides that are the same length. Let's see if we have another one. Now we're going to look at the distance for BC and DA. -2 minus 3, and then -1 minus 1. Again, looking at these 2 points here, x2 minus x1 and y2 minus y1 is how that's going to work. So negative 2 minus negative 3 we already know is negative 5 squared. They've calculated that for us. Negative 1 minus 1 is a negative 2. Remember, all negative numbers, even when they're squared, become positive. So 5 squared or negative 5 squared doesn't matter. You still get 25. And then 2 squared or negative 2 squared, it doesn't matter. You still get 4. So we're looking for a radical 29 on the length of BC. Final thing we need to check out is, does DA come out to that same radical 29 length? So again, DA is A and D here. They've already given us that the first x coordinate they want us to use as x2 is 4. So that means the other one has to be in the box that they're looking for. So 4 minus negative 1, and that is 5 in the next step. And then the next subtraction will be 4 minus 2, which is 2. So again, we have the same numbers. 5 squared, 25, plus 2 squared is 4, and yes, we do get a radical 29. So we're going to compare the side lengths. The lengths of the opposite sides are what? Of course, we know that they are congruent. Go ahead and put the little symbol there if you want to abbreviate it. And then what it's looking for here, you guys, is by the, oops, that's supposed to be an O, opposite sides criterion, which simply means if you have a quadrilateral with two pairs of opposite sides the same, then of course it is a parallelogram. Okay, so that's two different ways to prove whether something is a parallelogram or is not a parallelogram. And now we're going to do the your turns here at the bottom of this page. Your turn 4 and 5. It says write a coordinate proof. Again, just using the coordinates they give you. They give you A, B, C, and D, so make sure you refer to that for both problem 4 and problem 5. And then for number 4, just prove that it's a parallelogram. You can choose whichever way you want to do that. Looks like distance formula or slope formula would be acceptable. And then for number 5, it says prove that the diagonals of ABCD bisect each other. So I'm going to let that be your clue to which formula you want to use. Does the distance formula, does the slope formula, or does the midpoint formula talk about how things bisect each other? Remember that piece, and that'll lead you to how to do that problem. All right, we'll see you in the next video.